Good morning, my dear students. It gives me great pleasure to talk to you students through video presentations like this as usual. In this particular video presentation, we will continue with the remaining problems from exercise 7.5 on integration from NCERT textbook. The first problem meant for today goes like this. Is bx by x power 4 minus 1. Practically speaking, I am supposed to apply partial fractions. I'll give you an easier method. Just see here. The application of partial fraction tells you it is x square plus 1 at x square minus 1. Again x square plus 1, x plus 1 at x minus 1. Then the whole expression will be written as ax plus b by x square plus 1 plus c by x plus 1 d by x minus 1. It's a lengthy process. Instead, I'll do an easy method here. Here what I will do is, I'll write the numerator as x square plus 1 minus x square minus 1 dx divided by, the dx is anyway here, remember carefully, x square plus 1 into x square minus 1. Here x square gets cancelled. 1 minus minus 1, minus of minus 1 is plus 1, it becomes 2. Now to compensate, divide by 2. Just to compensate, divide by 2. Therefore, now make it as two integrals. Half integral x square plus 1 dx by x square plus 1 into x square minus 1 minus half integral x square minus 1 dx by x square plus 1 into x square minus 1. Here x square plus 1 gets cancelled. Here x square minus 1 gets cancelled. This is 1 by 2 log mod x minus 1 by x plus 1, then minus half tan inverse x plus c. It's an easier method to do. We can avoid partial fractions totally. It's a very simple thing. I'll just explain once again. X power 4 minus 1 can be written as x square plus 1 at x square minus 1. In the numerator, I'll be able to write it as x square plus 1 minus of x square minus 1. Here x square gets cancelled. 1 minus of minus 1 is 2. To compensate, divide by 2. Now make it into two integrals. Half, this is anyway half, sorry. Half integral x square plus 1 dx by x square plus 1 x square minus 1 minus half integral x square minus 1 dx by x square plus 1 x square minus 1. Here anyway, for the first one x square plus 1 gets cancelled. For the second one x square minus 1 gets cancelled. First one, the application of integral dx by x square minus a square, 1 by 2a log mod x minus a by x plus a. Next one is tan inverse x, therefore 1 by 4 log mod x minus 1 by x plus 1 minus half tan inverse x is the final answer. Then 16th one is very simple. Just see here, dx by x into x power n plus 1. See here, this is also very simple. I'll tell you an easier method. Just multiply and divide by x power n minus 1. Denominator is x power n plus 1. But if you look at it carefully, derivative x power n is n x power n minus 1. Therefore, multiply and divide by n in the next step. N x power n minus 1 dx divided by x power n into x power n plus 1 can be written as integral dt by t into t plus 1, where my t is x power n. Therefore, here again I can avoid partial fraction. I can write it as t plus 1 minus t dt divided by t into t plus 1. T gets cancelled. 1 can be written like this. Make it as two integrals. 1 by n integral t plus 1 dt by t into t plus 1 minus 1 by n integral t dt by t into t plus 1. But here t plus 1 gets cancelled, here t gets cancelled, which is equal to 1 by n integral dt by t minus 1 by n. You can very well write this as t of t plus 1, d of t plus 1, d of t plus 1, t plus 1, sorry. Both becomes log 1 by n log mod t minus 1 by n log mod t plus 1 plus c, which is reduced to 1 by n log mod x power n by x power n plus 1 plus c. That will be the final answer. 1 by n log mod x power n divided by x power n plus 1 is the final answer. I repeat, this is a question given to you. integral dx by x into x power n plus 1. Multiply and divide by x power n minus 1 within the integral. I can't take a variable outside the integrals. For this becomes denominator becomes x power n plus 1. But I should have a clear observation. Derivative x power n is n x power n minus 1. Multiply and divide by n. N being a constant, can be 1 by n can be taken out of the integral. This can be written as dt by t into t plus 1. And t is x power n. Dt is n x power n minus 1 dx. For write the numerator as t plus 1 minus t. Make it as two integrals. Here t plus 1 gets cancelled. Here t gets cancelled. For finally it gets reduced to 1 by n log mod x power n by x power n plus 1, replacing t by x power n. You can have infinitely many such problems like this. Integral x by x into x power 6 plus 1 will be 1 by 6 log mod x power 6 by x power 6 plus 1. Integral x by x into x power 100 plus 1, 1 by 100 log mod x power 100 by x power 100 plus 1 plus c. Method is same, the same way I should proceed. By having infinitely many values for n. For easy method, you just think of various natural numbers for n and then proceed. It be always easier for you to follow. Easier for you to follow. It is not at all difficult to follow. It is not at all difficult. I hope you are able to follow. I'll rub only this part so that I will continue with the next problem quickly. I'll just continue with the next problem. 17th sum, he says. For the 17th problem, he says integral cos x dx divided by 1 minus sin x into 2 minus sin x can be written as dt by 1 minus t into 2 minus t, where my t is sin x. My t happens to be sin x. See here, derivative of sin x is cos x dx. When t is sin x, dt is cos x dx. Now I can very well write the numerator as 1 minus t minus 2 minus t divided by 1 minus t into 2 minus t dt. See here, minus t plus t will get cancelled. There is an extra minus sign, therefore multiply by minus in the outside. Therefore, minus integral 1 minus t dt divided by 1 minus t into 2 minus t plus integral 2 minus t dt divided by 1 minus t into 2 minus t. Here 1 minus t gets cancelled, here 2 minus t gets cancelled. But everywhere derivative of 2 minus t is minus dt, derivative of 1 minus t is also minus dt. Therefore take this minus sign inside. This can be written as by 2 minus t. Write two minus signs here, minus dt by 1 minus t. Listen carefully. It is not at all difficult. You need to just understand carefully. I won't say it is difficult. Anyway, after completing, I'll explain once again. Just listen carefully. These easier methods will make you finish the paper in 2.5 hours out of 3 hours in your board exam. Therefore, this can be written as d of 2 minus t by 2 minus t minus d of 1 minus t by 1 minus t plus c will be outside later. This is log mod 2 minus t minus log mod 1 minus t plus c, which is log mod 2 minus sin x by 1 minus sin x plus c will be the final answer. Plus c will be the final answer. I'll just explain once again. It is not at all difficult. I'll just explain quickly. I'll explain the whole lot once again quickly. Just listen carefully. It is not at all difficult. If you replace t by sin x, dt is cos x dx. Now for the whole thing can be written, the second step is dt by 1 minus t into 2 minus t. Numerator can be written 1 minus t minus 2 minus t. Minus t plus t gets cancelled. 1 minus 2 is minus, and to compensate, multiply one more minus sign outside. Minus integral 1 minus t dt by 1 minus t into 2 minus t, minus into minus, plus integral 2 minus t dt by 1 minus t into 2 minus t. Derivative of 2 minus t is minus dt, derivative of 1 minus t is also minus dt. Now take this minus sign inside, multiply two minus signs for the second one. This can be written d of 2 minus t, this can be d of 1 minus, d of 2 is 0, d of minus t is minus dt. D of 1 is 0, d of minus t is minus dt. Now for log mod 2 minus t minus log mod 1 minus t plus c, for log mod 2 minus sin x by 1 minus sin x plus c is the final answer. That is the final answer. It is not at all difficult to follow. Just understand carefully, it is not at all difficult. Okay, just listen carefully. Now, for the next one, you just see here, for the 18th problem, you have everywhere x square. Whenever in any problem with everywhere x square, put x square equal to t only for partial fractions. Put x square equal to t only for partial fractions. Just listen how we go about it. X square plus 1 into x square plus 2 divided by x square plus 3 into x square plus 4 dx. Put x square equal to t only for partial fractions. Only for the real meaning of only for partial fractions means after the application of partial fractions, integration has to be done with respect to x. That is the meaning of only for partial fraction. Practically speaking, this becomes t plus 1 into t plus 2 divided by t plus 3 into t plus 4. I can't apply partial fraction here because, listen carefully, numerator denominator both are of equal degree. This can be written as t square plus 3t plus 2 divided by t square plus 7t plus 12. T plus 2t is 3t, 1 into 2 is 2, 3t plus 4t is 70, 3 into 4 is 12. This can be written as 3 square plus 7t plus 12 minus anyway 4t plus 10 divided by t plus 3 into t plus 4. Remember carefully. See here, 70 minus 40 is 3t, 12 minus 10 is 2. Always understand the methods given by me. Divide individually. This will become 1 minus 4t plus 10 divided by t plus 3 into t plus 4. Now I have to apply partial fraction for the second part. For the second part, I have to apply partial fractions. Just listen carefully. Just listen carefully. I mean to say, let 4t plus 10 divided by t plus 3 into t plus 4 is equal to a by t plus 3 plus b by t plus 4. Practically speaking, 4t plus 10 is equal to a into t plus 4 plus b into t plus 3. Now substitute t is equal to minus 4 in 1. We get minus 6 is equal to 0 minus b. For b happens to be 6. Now substituting t is equal to minus 3 in 1. We get minus 2 is equal to a plus 0. Therefore a is minus 2. I already told you, after the application of partial fractions, we are supposed to apply integration using x alone. It's the meaning of substituting x square equal to t only for partial fraction. That's the real meaning of only for partial fraction. Therefore, the whole integral now becomes integral dx. Okay, then minus 2 integral dx by first one is x square plus 3. Sorry, there is a minus sign here. If a minus of minus 2 becomes plus 2. Sorry, remember this minus sign also. I'm sorry. Then of course, minus of plus 6 becomes minus 6 integral dx by x square plus 4. Write this as root 3 whole square. Write this as 2 square. Therefore, this will automatically become x plus 2 by root 3 tan inverse x by root 3 minus 6 by 2 tan inverse x by 2 plus c. 6 by 2 can be written as 3. 6 by 2 can be in the next step, can be replaced by 3 anyway. It can be written as 3 finally in the next step. I repeat, whenever I have x square everywhere, put x square equal to t only for partial fractions. Then this becomes t plus 1, t plus 2, t plus 3, t plus 4. Since they are of equal degree, I should divide and proceed. Instead, there is an easy way to do. This can be written 70 plus 12 minus 40 plus 10. 70 minus 40 is 3t, 12 minus 10 is 2. Division by individually gives you this by this will get cancelled. 1 minus this. For the second part, apply partial fraction. Here 40 plus 10 is a into t plus 4, b into t plus 3. Now t equal to minus 4 will give you 10 minus 16 minus 6 equal to 0 minus b. For b becomes 6. Substitute t equal to minus 3. For 10 minus 12, 10 minus 12 becomes minus 2 is equal to a plus 0. 4 minus 3 is 1. A becomes minus 2. But there is a minus sign here. Whole integral now becomes integral dx. Minus of minus 2 is plus 2 integral dx by x square plus root 3 whole square. This is root 3 whole square. Minus 6 integral dx by x square plus 2 square. To apply the formula, make it as root 3 whole square. Okay, if you want, I'll rewrite this if you want. I'll leave this particular portion. This is root 3 whole square. This one is root 3 whole square. Okay, x square plus root 3 the whole square. Therefore, x plus 2 by root 3 tan inverse x by root 3 minus 6 by 2 tan inverse x by 2. 6 by 2 becomes 3. The final answer is x plus 2 by root 3 tan inverse x by root 3 minus 3 tan inverse x by 2 will be the final answer. It is almost 15 minutes. The rest will continue in the next video. Thank you students for patient watching.